Alright, so what I thought for today is to implement the brainfuck compiler in Zig. So if you remember from like day 5 or something like that, we did the brainfuck compiler in C, and it took us like 2 days maybe to finish it. And I'm thinking, well, how will it go in Zig, right? Will we finish it faster, or I mean, we already have the experience, I know what the compiler should look like, right? Because did it once. But yeah, now the plan is to just try to do it in Zig and see how it goes. And I mean, if you don't know what brainfuck is, it's like an esoteric programming language. It has only like what 8 symbols, right? It can move to the right or move to the left, like a Turing machine, right? It has these 2 symbols. Then it has an increment and decrement for the head, output, input, and then it has these oh my god, this annoyed me so much when we implemented the calculator in brainfuck. That was another one, like pretty interesting algorithm to do, but these are like for loops. So if I remember correctly, this one is if you have a 0, then you jump to the closing bracket, and if you have this one and you have non-zero, you jump back to the opening bracket. I mean, you jump to the command after it, but you know, it's basically a go-to, and this is the label. But at the same time, both of them are go-tos and labels. So yeah, I guess these are all the operations that you can do, all the instructions, and this somehow, for some reason, makes this language Turing complete. So it means you know, you can implement rule 110, game of life, like it's a complete language. You can do anything with it, but you know, I don't recommend it. Like making a simple calculator that adds to number was something like this, so it was extremely painful. This is the only part that I had to copy paste from someone else, but the div mode I tried to do it myself, but it was incredibly painful. To be honest, I don't think I can do this thing again. I mean, you know, I need to first I need more experience again with brainfuck to remember some things, like some tricks, because I remember this was a trick and stuff like that, but at this second I don't remember how to do it. Like, come on, what the fuck is this thing? But or I mean, maybe even worse, like all of this, right? But this thing was adding to numbers. So if we go to the repo, it's bf compiler, and I think, I mean, you know, the quick start, right? Oh, so this was the example so what's the calculator? 05. I don't even remember what was the input for the calculator. I think it was 2 numbers separated by space, right? Yeah. So yeah, that's the calculator basically. You put 2 numbers and it adds them. I mean, you know, it's just an adder, so not even full calculator, it just adds numbers. Okay, but anyway, yeah, let's try to zig this thing, right? So far in our zig project, in the last 2 days or so, I did reading from like reading and writing out right into the program, like the IO part. So right, basically we need to implement this part right here. So here we read, right, and here we write. So we need to implement this part when we do something with the input. So sure, we can like go through the file and try to, let's say, compare it step by step, maybe. Maybe that makes sense. So I guess for this one I had more things, but for I mean, you know, doesn't matter. I can change it to F, this, just to have the same flags, F and O for file and output. But I mean, here I had the argparse, so it was like my own parsing argument parsing library, so not fair to compare that. Okay, so we read the program, then we create a list of instructions, and we were parsing the instructions, right? And then we were checking, like type checking, and then we were generating the assembly. Okay, so fair enough. Let's try to do the same thing. So do expression, we are not gonna need this thing anymore. This was just for, okay. So let me just put here like an empty string or something. Okay, so the first thing was to create a list of instructions, right? Instructions parse. So let's do const instructions parse thing. I think this should work. Maybe it's gonna be like a try though. So maybe we are gonna have like a try catch, basically, is what I'm saying, like the, you know, question mark. So let's try and see how I was doing instruction parse in C. So I think this was pretty simple because it doesn't require a lexer tokenizer. Each let's say each character is an instruction in brainfuck, so we don't need to do any complicated multiple characters for one token. For example, when we did the cool language, you know, I mean, that's a real programming language, so we needed a special lexer, but in this one we can just go through the string. So let's see how cool Zig is with string stuff. I mean, this is not even like a string stuff, it's extremely simple, but okay. So how can we do this one? So we need a function, instructions parse, and it should take in a U8 array, and I think we can call it program. And in this one I was passing as a reference the instructions, right? And but this was mainly because we don't have dynamic arrays in C, so I had to implement my own dynamic array with the append and stuff. So anyway, let's say that we have an array of, I think, I guess token type, right? I guess token kind, let's call it, and let's use capital letters. I think this is the way to write types in Zig. So return token type, any error maybe. Okay, so let's see how can we define enums in Zig. So it's gonna be the same as the structs. And for the stuff that's inside, okay, let's see, Zig enum docs enum. Okay, I'm curious. Oh, enum u2. Okay, so it's gonna be like enum u8 basically, I guess. But whatever, doesn't matter. So we have move right, and I see they're lowercase and underscores. Okay, so it's gonna be move right, move left, increment, output, input, jump forward, and jump backward. Right, so I don't know, but I guess doesn't matter. Okay, so now we have the token kind. Perfect. Can I have a while through the iterator or something, like while program dot next or something, and then it's basically token. Oh, I'm not doing something right. Wait, it doesn't work. Zig iterate array. Oh, perfect. So for array token, like this. Okay, perfect. So afterwards I was using this case like switch statement. Let's see if we can do the same thing here. So switch token. We don't get any errors though, like for missing cases. Oh, Zig switch. Okay, so in this one it actually kind of works to have like const kind and then maybe, oh, but I need the array. Was it like this? I don't know how to append to it. But I guess this one is pretty cool, and then else that's cool. So a zig append to array. But I don't care about, what compile time. It should be in zig by example. Or in arrays. Yeah, like maybe what this is like. Yeah, but I was more curious how to append, like how to append to an array, right? Maybe create it with a certain size and then using that. I don't know how I feel about this, but maybe it's not like dynamic array, so let's do like program.len. And can we use undefined? And then, for example, I saw here in the for loop that it had, where was it? Here. That it also, oh, I see. It also has like the index. So like, that means okay, we can try to do the same. So I okay, so then like tokens I is equal to kind, basically. Okay. Oh, and here I made a mistake. Should be token kind. Okay. So now we just have to do these kind of things. So do I do token kind dot move right? And this should be arrow. Okay, like this. Then we should have the plus minus for increment, decrement, output and input. I don't remember which is the output is dot. Okay, perfect. Then we have jump forward. Oops. Okay. And else can I do something like I don't know how to do like error. Unreachable. I mean, it's not necessarily unreachable. It's like well, at this point I think I didn't really know proper parsing, so maybe invalid like this, and here we should return token kind of invalid. I think that's the way to go. Okay, so maybe this thing shouldn't return should return just token kind. I mean, you know, can it fail for some other reason? I don't think so. Okay, so this just creates the tokens. Okay, so we can just return that. I was looking at the switch. Am I right? Okay. Okay, anyway. So that's how we do instruction parse, but without try. So we get token kind. Okay, so in instructions, inster std debug. Let's try to print them. I don't know how to do that, so and I think this should be like okay. Excuse me. Okay, so how do I say the size of the array then? So should probably be zig std array. So I want maybe an array list then. Array list token kind, right? And it's std array list. Okay. Oh, so this is the init. I need to call init, and it wants an allocator. Let's just do that. Okay. And maybe with this one we can just append stuff. Okay, we can just append, that's good. To owned slice, right? So this can return error. I assume that I can do like try. Okay. Oh, I have to use try here as well. Oh, interesting. Yeah, I mean, I didn't think about this, but append can fail because of the memory allocation. And now it doesn't like the printing of token kind. But zip print in. Okay, whatever. Can I oh, interesting. Oh, I see. Okay. So it gets these, that's good. But then it's token invalid because why would that be? I guess read file is not 100% right. Because we might have zeros at the end, so would maybe make sense to remove all the zeros or something. Or like append slice, but maybe there's a similar function. Append size, assume capacity. Huh. Can I like 0 up to size it? string buffers. I mean, I looked at this one before, so like I just wanted like this. Okay, that's what I needed. One up to size, right? The fuck? Expected. What? Expected array of U8 found? What the fuck? I mean, how is it not the same thing? Const slice is gonna be this thing, right? How is it not just slice? Okay. So it still appends all this crap. But why though? Okay, you know what, like okay, I'm curious, maybe the size is not right. But if the size is gonna be right, I'm just gonna do a for loop. I don't even see it. The fuck? Oops. Let me just remove this thing. It doesn't show anything, what the fuck? Oh, maybe because, oh, fuck. Yeah. Because I forgot to do it twice. Okay, fair enough. Right, so we have the enum just like this one, and then our matching brackets result, but this one is gonna be the inverse, other way around of this one, because for us okay is gonna return void and not okay is the index, right? So that's how I think it should work. I just copy pasted this, right? So okay, so then we can do complex type. Okay, perfect. So this thing should return matching brackets. Okay, let me just see how I did the algorithm because I don't remember. So I iterated over everything. Pretty weird. So var count is gonna be 0, and then we need to iterate over the instruction. So instruction and then 0 up to something kind I. Okay, so if kind jump forward, so if we have a jump forward, we need to, oh, now I understand why I used the dynamic array. I wanted to have like the index to say which was unmatched. Oh. Well, you know what, like, sure, let's do it with the array. So then, because we already know how to make arrays, it's not a big deal. So this is the counter basically, and it should just have ints in here, so u32s. Okay, and we can defer counter the init, because this time we don't care about the counter. Okay, so if that happens, we add the index. So that's just adding I. So counter append I. All right. So we try to append I, which I'm in new size. Fair enough. Okay, and then if we find a jump backward, so is equal to, if we find jump backward, we have to check something like if counter dot length size, but it's not capacity. Pop or null. Get last or null. Okay. So we try to get last or null. Pretty much. Oh, we should maybe pop or null actually. Let's do like last, which I don't think I even care about it. Wait 1 second. Yeah, I don't care about it. Like, if it's there, I guess it's there. But if it's not, I don't know how to do the reverse. But I guess if it's not, then we just do the error. So matching brackets, let me just see again, and we can just pass not okay I. like this, right? I mean, sure, fair enough. Honestly, it looks better than the C version, but yeah. Okay, so I guess after the for loop, if the count is not 0, it's an error. So if counter dot, I mean last or null works. So if we have any elements, oh, can I do get although yeah, I think I should use last here. So you know, this time last is fine, I think. Wait, what? Oh, I have to use equal. And here it's last. And otherwise we just return matching brackets. Okay. Okay. And I mean this should probably be usize. Okay. And then, you know, I just did matching brackets or something. So switch. Well, first let's do const matching is equal to matching brackets, pass in instructions, switch matching. If we have okay, then I don't know, we don't do anything. Well, yeah, if oh, this should, yeah, any error, because we have this append, I think this should work fine. Okay, so this should be like try. But it's cooler to do it with switch, because I think we can do pattern matching. So if it's okay, then I guess nothing. Oh, can't I just have a switch like this? Okay, perfect. So it's by tag. Okay, matching brackets tag, not okay. Index, and now we can just print something like oh, I guess I had two kinds of errors. So not okay, let's say jump forward, not okay, jump backward, use size, because I know for not okay, jump backward. And I guess first one is jump backward, obviously, and this one is unmatched jump forward. So if we have the jump backwards version, it's gonna be unmatched jump backward. Oh my god, even display error is a weird ass function. Bruh. Okay, so display that's a bit annoying, but yeah, it's fine. Display error, and we can pass in like program index, and just copy paste the error basically, I guess. And let's say jump forward or something stupid like this. How do I don't do anything there? So display error, right? First we need a program just to be able to count stuff, then index, use size, and then description or something. You wait. And I guess it's gonna be void. Oops, void. Okay. So now we need the line and the column. So like this, and then we need to iterate the index. For 0 to index, I guess we get an I, okay. And maybe if program I is equal to new line, line plus plus, line plus 1, and column is equal to 1, else column increases by 1. Okay. And then we have to print something like this. So it's, oh, I guess we also could use the name. right? So it's gonna be std debug.print. Let's do S, let's do a D, another D, and then another S. So it's gonna be like name, line, column, desk, right? Display error. But it also wants, oh, let's make this one optional. And let's do something like if name else we just do this thing. Whoa. Okay, what's the mistake? But how do I initialize this thing? I saw it like this. Oh, I guess just like that. Lame. Expected. Oh, what? Oh yeah, I mean my args.input. Forgot about that for some reason. Okay, interesting. Oh, so the last one can be const or something. What? So like const? Huh. I thought 180. Wait, what error? Oh, because I put here the exclamation point, but it's not needed. Okay, so this should work. The fuck? So it's gonna be jump backward, jump. You know what? It's I have to put new lines here just to see anything. So it didn't. It did. Wait, what the fuck do I did do backward, forward, backward? Maybe I fucked up in the switch. Okay, what? std.debug.print. Can I do a character for the token? Excuse me. Yes. More annoying printing, I guess, than C, honestly. Okay, so why did it skip the... Okay, let's not talk about it. Let's pretend that never happened. Okay, now it works, and if I do something like this, it should say unmatched jump forward, perfect. And if I do something like this, it should be unmatched jump backward, correct, yeah. And if I do it like this, it should be at what, 1 1 2 1 3. Yeah, so it works. I mean, you know, kind of works, so let's not worry about it for now. Let's remove the stuff. Okay, so we have the semantic check, I guess would be, probably. So, you know, the last thing is to just generate the assembly, and you can say output or something. I mean, probably it's gonna be like a try. And at the end, can I do maybe something like defer? I cannot. Okay, whatever. So now we have generate assembly. So it should take in a list of instructions. So I guess token kind, and it returns any error or U8 array. Wait, it's array U8 anyway. So here it's instructions. Okay, perfect. Huh. You know, would be easier to but maybe Zig string builder, but it's the same as a linked like dynamic array. So let's say here buffer is gonna be U8, init it whatever, buffer slice to owned slice. So that's how it's gonna go. I mean, I'm just gonna copy paste this stuff, and let's see if we can do something like buffer append slice, I think. Okay, hopefully it's not gonna complain about the things being const, but whatever. So we have that, then we have a new line. Looks like, what the fuck, CI, okay. Then we have generate assembly block, another one of these, and then all of this crap. Okay, so again buffer append slice. You know, I mean, I can even do buffer append slice, and then at the end whatever, we don't care about that. So now we want generate assembly block. Well, I guess it makes sense, right, to follow this this thing, because I don't remember how how I did this entire thing. So copy pasting it, I would say it's not that big of a deal. But first let's see if it runs. Wow, that's honestly, that's a bit annoying. Instructions. Oh shit, I forgot about that. So all of these need fucking try. Come on. Okay, so we have something. Okay, I mean, we have the assembly, that's perfect. Oh, and if I remember correctly, here I used the NASM assembly, so yeah, it is what it is. It's not FASM, but it's still fine. Okay, interestingly enough, here we have generate assembly block. So the generate assembly block was it? I mean, I don't know, honestly. Yeah, sure, whatever. So let's try to implement it the same way. The fuck did I do? Fn generate assembly block, so it's gonna be instructions, and we also need a pointer to the index, so I think view size is what we need. And maybe this should also take in the buffer as a pointer. Buffer is gonna be std array list u8. Can I say like this pointer? So it should return any error or void. Without that, okay. So now we should have this kind of while loop. Instructions.len. I guess we need to dereference it. Probably. And then we need a switch. So switch over instructions index or something. And then we have some things there, but the interesting one, I would say, should be jump forward, because jump forward creates a new block. Or I guess the easiest one is token kind jump backward. This is going to be the last one, so this one doesn't do anything, it just returns as it seems. So it basically breaks, right, like return. and in here we can do something like index +1, right? Maybe, I don't fucking know. Let's try to... Okay, this one I don't know how it appeared there. Oh, the fuck? Oh. What the fuck is wrong with the... Okay, I mean... The fuck is wrong with the LSP? Bruh, what? Are you fucking stupid? Maybe he doesn't like this star? You know what, like let's leave it out, let's see what the compiler has to say. Okay, and this one is generate assembly block. Dumbass. So that should be a reference. These are the instructions, and index again like a pointer. Okay, let's see what the compiler has to say. What the fuck? What? It's use size. Cannot you infer that? Ooh, and now it's gonna be fun. Wait, what? Oh. Okay, now this is lame. But I mean, no, it makes sense. It's the same as for okay, let's do else return just to make it shut up. Shut up. And I guess this one is gonna be try as well. Oh, and now it just didn't do anything. So, okay, what the hell? Oh my god. This is gonna be fun. Can I do this? Let's try. So D is nuts, index, and we dereference it. What? Oh, yet again the same error. Wait, I don't see the... Wait, what? Oh, it's 0, but only 1 0. I wonder why. Oh, because it got return there or some stupid like that. Okay, fair enough, now it works. So I guess on the else case it's nothing, but we don't even need the default case because the default case is not gonna happen. Okay. So now it's token kind jump forward, which might be more interesting. So we need a label. So we need to generate assembly jump forward basically. And the label is gonna be index star. So that's that. Then we increase the index. Wait, why did I delete this thing? I have no idea why though. So we increment the index, then we generate the assembly block again. So generate assembly block, pass in the buffer, instructions and index, and then we do a jump backward. I guess we just assume that the jump backward is gonna be there because we type checked it. So oh, that's why we needed const label index.star. That's why we needed a label. Okay, fair enough. So now let's do the functions. So this is gonna take in buffer, label is gonna be usize, and I think it should probably return any error or void. So these are gonna be tries. Okay, good. So I would just say we just copy paste this stuff. I mean, you know, if you want to see how I actually thought about these instructions, you know, it's the brainfuck compiler in C, but probably will be a link to it. So yeah. Buffer. Okay, so it's try buffer dot append slice. Okay, fair enough. And the other one is gonna be similar, but it's for the backward version. So jump backward, it's gonna be like this. So we have to do try buffer append slice. Okay, so I guess let's keep else for a bit. Let's see what's oh no. How are we gonna format the string? std fmt format, I guess. Yeah, is it it can return error. So try. So it should be something like this. should be something like this. But quick question, can I put it in, like, does it matter? I don't think it matters. Perfect. That's what I wanted to hear. Alright. And this one as well. std, the format. So the I guess this thing first needs to be like that. I guess this is why I should have wrote directly to the file instead of to a slide, but it's whatever. It's oh, what? Whoa, 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 what does format take in? Fucking writer? Okay. Zig sn printf, or I guess s printf, that's what I need. List writer dot print. Huh, okay, I mean, let's see. Then let's go back. Well, actually, no. Writer dot print. Okay, but what? Delete until this. Huh. I guess I should use this thing everywhere if it works. I think. Writer dot print. Like if this thing works, I'm gonna use it everywhere. Okay, yeah, so it works. Then actually no, because it also wants the args. Anyway, let's keep it like this. Okay, so what's the next thing that we want to do? Maybe, like, I don't even think it matters that much. So move right, for example. Move right. Okay, and for this one, for move right or move left, increment and decrement, I also did like optimization. So if I found a move right, then I try to go like to the next instruction and see if it's again move right. So we can also do that here, just to have the most optimized version. So we can do another while index instructions len, and I guess obviously we need end instructions index +1. Well, I guess here I said -1 for some reason. Token kind of move right. So as long as this is the case, we do count plus plus. So count is equal to count +1 index increases as well, and then we generate assembly move right basically. And I think that by default in Zig the cases are not fall throughable, so that's a good thing. So generate assembly move right. Let's have something similar to this. So it's move right count. It's count? Yeah, but like doesn't matter. So generate assembly move right. We had like two options. So if the count is 1, then we just try buffer append slice. If it's not, well, I guess this is the comment, so holy shit, we have to do this one. But oh well, yeah, I guess I have to delete that, like D0 or something. Try buffer writer dot print. Okay, let's put all of that. So I think this is move right. Let's do move left. I mean, move left is gonna be just deck or sub, if I'm not mistaken. Yeah, deck or sub. Now let's do all of them because it's gonna be easy. Actually, what was it called? Increment? Yeah, increment should take this thing. It also takes in the count, I'd say. Yeah. So increment for these two is just gonna be try buffer append slice. Nothing that special. Well, more of them are gonna have the same treatment, let's say. Also this one, but again this one is buffer writer dot print. So like this. Great. So the next one is decrement. And decrement should be again like deck and probably sub. Okay, so let's do more of them here. So if we have move left, then again we iterate over them, and while we find move lefts, we increment the count and we do this. And I think that increment and decrement are going to be exactly the same. So I think they are exactly the same. Okay, and here it's increment. This one as well, decrement. And decrement. And I guess output and input are gonna be just that. So let's see if it works or what. So it's where we have the var count, use size. Like, can't it just figure out that it's use size? Because it's used here? Weird. Oh, I forgot about the try catches. Try. And maybe at least this try statement makes it a bit more obvious compared to the Rust question mark. So something happens, right? So cannot say for sure if it works yet because we need output and input. So let's remove this thing, and I guess the last two things that we need to add is input, generate assembly input. This one just needs the buffer. Okay, whoopsie. And generate assembly output is like that. Okay, fair enough. So let me see how the... Oh, it wasn't that painful. It wasn't painful at all. Holy shit. Try buffer append slice. So that was basically the input, and let's do the same thing for output. I guess. Okay, let's do it like this. Let's put them like that. Okay. So this should be assembly output, right? And I guess the easiest way to do it is again copy paste the assembly generation, try buffer append slice. I think that should do it. Okay, so we have like 350 lines. I mean, I copied most of these from the C project, so we have that. But let's try to find the hello world example. Oh, I had like a hello world basically in brainfuck. Hello.pf, right? doesn't even have LSP. Okay, so the file is gonna be hello. Oh, we have invalid token. Okay. I forgot about the invalid token. So token kind invalid. We don't do anything yet about it. Like, oh, if it's invalid though, it was actually used as a comment. Like anything else, maybe instead of this we should say comment, because any other character is used as a comment. Wait, what? 240. So we have something like missing a try. So we get some assembly. -o hello, or I guess example.asm. What the fuck? I guess I have a debug somewhere in here. Okay. And then we can just do this thing and then example. Holy shit, it works! It works, dude. Let's do the calculator. Let's see if it's gonna run the calculator. So this one is gonna be calc. It's a bit slow. Huh, interesting. And it's like a calculator with I think variable precision. So it's okay, it's not. I don't remember exactly. Does it have to have the same amount of? Yeah, I think so. It needs to be aligned. Holy shit, the calculator was bad. So it's 50 and 29. Oh, I missed. But now it's fine. So yeah, it needs to be. So if I do this thing, 1 2 3 4 5 6 7 8, is it right? I think so. So it needs to be, the numbers have to have the same length. I didn't know how the fuck to do it otherwise, so it is what it is. So yeah, the only way to do it, honestly. So yeah, holy shit, we actually did it. It's 350 lines, and I guess the C version is much longer. But if we take a look, I feel like the Zig version is slower. So 0, like almost 1 second. And if we go here, okay, I mean, I cannot say for sure because I need to compile. It's not even taking time. But maybe it's also the build that takes time. But no, it's just faster. Yeah. Well, we can try to use the executable. So zig out bin. Ah, now it's faster. I mean, maybe it was zig build. So like in time, 3 milliseconds or something. Well, it's the same. So yeah, I guess as a performance, the language is the same as C, basically. I mean, for this really simple example, but yeah. But I feel like it's like a mix between C and Rust, and in my opinion, why not you just either go all in on C or all in on Rust? Like, I feel like a middle ground between them is not really that useful. Maybe, you know, if you are really struggling to learn C, maybe this is a better alternative because it has the same mechanics, let's say, of allocating and deallocating memory. It also has pointers, so it's pretty much the same as C, but it's more friendly in a way. Although I don't like how printing is worse than in C, honestly. But I mean, okay, yeah, fair enough, whatever, it's fine. But yeah, other than that, you know, obviously it's better because it has dynamic arrays, it has data structures already in the stdlib, so it's better that way. But yeah, I feel like, you know, if you know C, why not just use C? Because I'm like, you know, 99% sure that if you are a C developer, you already have data structures in some way or another way. Like maybe there are libraries that you can use, so you know, not a big of a deal. And on the other side, I mean, I feel like Rust, I don't know, the error handling feels better in Rust. So yeah, I mean, it feels like a middle ground between the two languages. It's much simpler than Rust, and that's a good thing, because it, you know, it's like it took me what 3 days to get a grasp of the language, so that's a good sign. But yeah, I feel like it's I don't know, you either go C or you either go Rust. I don't see why you would go with Zig, other than, I don't know, you cannot learn either of those. This is a simpler version, so yeah, maybe that's the reason. But honestly, if you cannot get the hang of C or Rust, I feel like Go is the other better version or alternative. So yeah, yeah, I mean, I don't know, I mean, I enjoyed this, but I feel like you have to think more than when you program in C for some reason. So yeah, I mean, I like to be completely brain dead when I program, so C is perfect in my opinion, because you don't have to think at all when you do C. I think, I mean, I don't even know, but yeah. And Rust is on the opposite. You have to think too much. So really dislike. I mean, I'm just kidding. Rust is pretty cool because you do like all those weird types. That's fun, like a puzzle, but useless sometimes. So yeah. So I don't know. I guess Zig is a decent middle ground between C and Rust, right? Maybe it's a good way to transition from C to Rust. That's another thing, but that's just sad, honestly. But yeah, I mean, knowing that Zig allows you to do really easy interop with C, that's a plus. And I also like that you have types as values. That's really cool. Like for example, where was I mean, if you saw, like, there are compile time things, comp time t type, see, like you can pass u8 here as the argument, but that's just generics, so yeah, not even this one is special about the language, because this is just generics. But maybe it's more powerful than generics, I don't know. Would have to see a use case like that, but yeah. And I don't know, error handling, I mean, pretty standard nowadays. I guess people started to understand that errors as values are better. Obviously they are better than throwing, like, imagine having to throw errors, dude, in 2024, like, that's crazy. Using try catch, yeah, that's insane. And this way of doing it is extremely good. Like, you literally see that this function returns an error, and yeah, you see that here. And yeah, how even what I said earlier, that I like this thing more than the Rust version. In Rust you would put like this, and maybe if you look at the code, you glance at it, maybe you miss it. So, but with a keyword that stands out, you cannot miss it, right? But I mean, yeah, so it's much better. And I think you even have like the catch, so if you want to handle the error in some other way. Here I mean, in all my Zig code so far, I just threw it out, but I guess you can do something like if and then catch error, right, and do something with it or something like that. But I mean, I didn't have the need to do it, so yeah, basically just that. So yeah, I feel like, you know, it's maybe it's worth a shot to learn Zig, but yeah, I feel like if you already know C, then continue with C. I don't really see this as a extremely huge improvement. I mean, if you are really good at C, then there's no point in learning Zig. But if you are completely new and you are like, oh, I kind of want to learn C, maybe Zig is a better starting point, because it makes some things easier to understand, like memory allocation and stuff. But yeah, I mean, I don't know. It was easy enough to do this compiler, so. But I mean, most of the compiler was I mean, you know, let's not consider this, because this is just printing the stuff. We already had the stuff, so we just had to print it. So I guess the interesting stuff was this switch and maybe displaying this error, I don't know, matching brackets like this maybe was a bit interesting to see how you do it in Zig with this kind of pattern matching stuff. Oh yeah, and also pattern matching is really important nowadays, right? Like, if you don't have pattern matching in your language, the language sucks. So yeah, like, a good language needs to have like errors as values, pattern matching, data structures in its standard library, and some decent enums, right? I mean, these are decent. So I think, yeah, those are all the requirements in my opinion. So Zig, yeah, it hits all of those, so it's pretty good. But yeah, I mean, you know, we actually managed to get the calculator again. after like one. Oh shit, actually, yeah, it's like we actually managed to do the calculator after 100 days, because that's, I think it's day 106 or something. So yeah, 100 days later we did the calculator in Zig from C. We upgraded, if you can call it upgrade. So yeah, I think I'll just put, I mean, I don't know if I want to do a separate repo. I might just make subfolder in BF compiler with the C version and the Zig version, so you can compare it easier, right? You can see, oh, that's how you do it in C, that's how you do it in Zig, so you can compare it for yourself, right? Because I don't know, like, but yeah, I would say that this is the meat of the thing, because the rest is just printing strings, so it's not important. So yeah, but yeah, we actually managed to do the compiler, so I guess that's it for today, and we'll see in the next one. So see you.